Forget childish pranks. What if Kevin McCallister wasn't just a resourceful kid, but a tactical amateur engineer conducting live field tests of defense systems? His home wasn't a place of chaos, it was a proving ground. Today, we're conducting a tactical engineering breakdown of every one of his traps. We'll rate them on two criteria: efficiency and engineering ingenuity. Let's find out which were acts of genius and which were just dumb luck. The first phase of any defense is to delay and demoralize the enemy. Kevin starts with a micro-engagement. Let's look at trap number 1, the stair nail. Objective: inflict a targeted penetrating wound, reduce mobility. Mechanics: a nail taped to a wooden step, point up, a classic caltrop in miniature. Efficiency rating: 9 out of 10. The physics are simple and brutal. All of Marv's weight multiplied by the acceleration of his fall focused on the nail's point. Result: a deep puncture wound. The only failure was using just one nail. Ingenuity rating: 6 out of 10. Reliable but primitive. Now, trap number 2, the rope and iron. Objective: inflict blunt force trauma to the head. Mechanics: the iron on a rope acts as a primitive battering ram. Energy transfers from the falling weight through the rope. Efficiency rating: 4 out of 10. Harry ducks in time. The main force of the swing missed its target. This is a failure in trajectory and weight calculation. A heavier weight and a shorter arc were needed for a reliable hit. Ingenuity rating: 7 out of 10. Points for utilizing potential energy. Realizing a full-scale invasion is underway, Kevin shifts to active defense, creating kill zones at key choke points. Trap number 3, the Paint Can Pendulum. Objective: disorient, cause concussive force, potential cranial trauma. Mechanics: this is a near-perfect physical pendulum. A can of paint on a rope swung from the top of the stairs. Its potential energy converts to maximum kinetic energy at the bottom of its arc. Efficiency rating: 10 out of 10. Direct hit. Maximum force applied directly to the face. The timing and pendulum length were calculated flawlessly. Ingenuity rating: 10 out of 10. The apex of his engineering. Trap number 4, the Blazing Doorknob and hot iron. Objective: inflict thermal burns. Mechanics: Kevin exploits thermal conductivity. He heats the metal doorknob with a blowtorch and the iron via its own element. Metal rapidly absorbs and transfers that heat. Efficiency rating: 8 out of 10. Second-degree burns are guaranteed. The flaw is the need for constant heat application, which is energy inefficient. Ingenuity rating: 8 out of 10. High marks for understanding material properties. With the enemy enraged and reckless, Kevin deploys direct and systemic traps. Trap number 5, the silver-toothed roach and blowtorch. Objective: induce panic and secondary injuries. Mechanics: creating an uncontrolled pyrotechnic reaction. Flammable aerosol plus open flame. Efficiency rating: 7 out of 10. Tactically effective. Panic and burns were achieved, but it has critically low controllability and high risk to the defender, a weapon of last resort. Ingenuity rating: 5 out of 10. Brutal and risky. Trap number 6, the basement stair and crowbars. Objective: inflict compound injuries from a high fall followed by impacts. Mechanics: a classic engineering principle, removal of support. The stair treads are replaced with loosely set crowbars that rotate under weight. Efficiency rating: 9 out of 10. A 3-meter fall on a hard surface guarantees fractures. Ingenuity rating: 9 out of 10. Simple, elegant, lethal. The best trap in terms of setup to result ratio. So, was Kevin a genius? By our metrics, yes, with caveats. His strength was improvisation with household items and an intuitive grasp of basic physics. His core tactical error? The lack of a unified, activated system. His traps were disparate. A true defense engineer would have created a centralized sequence triggered by one switch, trapping the bandits in a fatal cascade. His core engineering principle? Escalation through pain.
each new trap exploited the rage and carelessness caused by the pain of the last one. He wasn't just building barriers, he was actively managing enemy behavior, forcing them to act irrationally. So, next time you watch Home Alone, see it not as a comedy, but as a textbook on partisan home engineering, where every piece of string, every can of paint becomes a component in a defense system. And Kevin McCallister himself, an innocent yet formidable tactician, who proved that in defense, it's not about strength, it's about the right calculation. Stay curious and always check what your ladder is resting on.